Problem number 3. Number of absences and number of missed quizzes. The following data shows number of absences and the number of quizzes missed by 5 students. Solve for the correlation coefficient and test its significance. If there is a significant relationship between two variables, predict the number of quizzes missed by a student who was absent for 6 days. The data below is given. The first column is a student number. You may disregard that. The second column is for the number of absences, and the third column is for the number of missed quizzes. We need to first check what are the dependent and independent variables. We can paraphrase it this way. The number of missed quizzes depends upon the number of absences. So, if you have more absences, you'll have more missed quizzes. Our dependent variable is the number of missed quizzes, and our independent variable is the number of absences. Then we solve for the correlation coefficient. You have this one in our previous topic. So we add 3 more columns, x squared, y squared, and xy. Then we need to square the x column, you'll get the x squared. Square the y column, you get the y squared. Multiply the x in the y column, you'll get the xy column. Here's the completed value. Then, you need to summarize to sum it up the data for each of the column. Then after that one, we need to substitute these values. We go back to our formula. The values of our letters to the given values. As we compute it, the value of our R is 0.63. So we now have our correlation coefficient. We need to test if this correlation coefficient is significant or not. So we state the null hypothesis. There is no significant relationship between the number of absences and the number of missed quizzes. The alternative states that there is a significant relationship between the number of absences and the number of missed quizzes. Then we compute for the value of t. Remember that, let's go back to the problem. Our R is 0.63 and we have 5 students. So our N is 5. Let's solve for the value of t. Pause the video if you want to have time in solving it. The value of our t is 1.41. In step 3, we compare this value to the tabular value. If we check, our degree of freedom is 3. That's 5 minus 2. And if we use our t table, our critical value is 3.182. And our critical value is greater than our computed value 1.41. If you draw the normal curve, 1.41 is found in the acceptance region. Thus, we do not reject the null hypothesis. We state our decision and conclusion. We do not have sufficient evidence to reject the null hypothesis. Thus, there is no significant relationship between the number of missed classes and the number of absences. Then you may ask, should we proceed to regression analysis? There's a note there. Since there is no significant relationship between the number of absences and the number of missed quizzes, then we will not proceed to regression analysis. Thus, the number of absences cannot predict the number of missed quizzes.